Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of mill turn on this part. If we take a look at our coordinate system manager, you'll note that we have home positions for our Mac 1 as shown over here. 2, 3, 4, and 5 used for milling, and this one here as well, which is used for the turning. Basically, when using mill turn, you have to create your different home positions for the different operations that we use, whether it be your turning or your different positions in your milling on the part. Let's first take a look at some of the operations that we have here. And we'll start with the turning operations. Note all the turning operations are working on Mac 2 position 1. They're all working in one position as turning works in one position. Taking our first operation, we did a turning operation on the outside of the part as shown over here using an external roughing tool. And in our technology, we use the option of rough, long external, and we have descending motions. Quick look at the simulation. You'll see that the tool actually goes in and doing a cut on the outside as shown over here. Now we have the rest of our turning operations as shown in the simulation here, including turning, drilling, and another profile turning operation over here. Taking a quick look at the simulation, you'll see that we have the turning operation for that area as shown over here, doing the finish cut on this entire area. The drilling operation going inside the part, and then one more turning operation to finish the inside diameter as shown here, including this indented groove as shown over here. And now we're ready for our milling operations. Now we'll start with our milling operations. First, we're going to mill out this area. So for that, we bring it to our proper Mac position, in this particular case, Mac 1 position 1. Taking a quick look at the operation itself, it's a regular profile operation in milling. Showing the geometry, you can see it's this area over here. Using the proper tool, as shown over here, with its levels, regular milling operations as in any milling operation. Taking a look at the simulation, you'll see that the tool will go in and create the slot as shown over here. Next operation will be a drilling operation for these holes and this hole over here. We can see that over here, and we can see that for this operation over here. Regular drilling operations all in Mac 1 position 1. Now next, we've gone and done a pocket operation on this surface over here. For that, we have our pocket operation. We have our geometry as shown over here, and we have the proper tool needed to machine that surface. Our levels, our technology, and running our simulation on the part, you'll see that it mills out that surface, and it milled out the opposite surface as well, because we have used the transform option of rotate a fourth axis in this operation over here. Now for our next operation, we used a drilling operation to drill out these holes over here as shown in this operation over here. Next, we went to our next position on the part. In this position, we milled this area over here, this slot over there. The operations done in this slot is the very same that was done in the slot on the other side as well. Next, we've gone into our next position where we've done a drilling operation on this hole over here and a pocket operation on this surface over here as well. In our next operation, we've done the same thing as in these two operations, except this time it's on these two holes as shown over here, together with its respective pocket operations as well. And for our last operation, we did a wrap operation on this area over here. Let's just go into this operation itself. You can see we're using Mach 1 position 2. The geometry in this particular case is this area over here. And note that if I were to go into the geometry itself, we're using the wrap option for that, as this has to be done towards the center using the fourth axis of the machine. The tool will be the proper end mill needed for this operation. And if we go into our technology, you can see we're using a regular contour option for our pocket. Our levels are up until the proper surface. And if we take a quick look at the simulation itself, you'll see that the tool goes down and actually works around inside that pocket, completing that entire pocket using the fourth axis of the mill turn machine. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.